So today we are going to do our water investigation where we are trying to figure out if the mathematical model that we developed earlier will work for energy transfers between two liquids. So make sure that you have your science notebook out with your data table already written in it before we get started here. So the first thing we need to do is we need to zero the mass of a cup and a lid. Because when we take our mass, we want just the mass of the water. We don't want the mass of the cup. So I'm going to press the tare button, and now the balance has subtracted the mass of the cup. For this first trial, we're going to combine warm water with cold water. So I'm going to start by putting the warm water in 1 cup. I'm going to put the lid on. The mass of our warmer water is 215.4 grams. So 215.4 for mass of warm water. Then I'm going to take our cold water and I'm going to pour some cold water into the other cup. The mass of our cold water is 114.3 grams. So 114.3 for mass of cold water. Now we need to take the initial temperature of each. So we're going to start with the temperature of the warm water, and we're going to be measuring temperature in degrees Celsius. And we usually want to wait a little bit so that we make sure that we're reading an accurate temperature on our thermometer. The initial temperature of our warm water is 21.9 degrees Celsius. Now we're going to do the same thing for the cold water. I'm going to put the thermometer in the cold water. Give it a little stir to help it read an accurate temperature. So the initial temperature of our cold water is 6 degrees Celsius. So now we're going to pour 1 cup of water into the other. I'm going to put the lid back on, and I'm going to give it a little bit of a swirl to kind of mix our 2 water samples. And then we're going to wait for the temperature to stabilize. And it looks like the final temperature for condition number 1 is 16.2 degrees Celsius. Now we're going to repeat these procedures with 2 other water temperature combinations. This time we're going to use warm water and just cool water, so not as cold as last time. So this time, for condition number 2, the mass of our warm water is 98.5 grams. And the mass of our cool water is 143.4 grams. Once again, we're going to take the initial temperature of both of them, starting with our initial temperature of the warm water. Looks like the initial temperature of our warm water is 21.6. Looks like the initial temperature of our cool water is 6.5 degrees Celsius. Once again, we're going to pour 1 cup of water into the other. And we're going to give it a little stir to mix our 2 water samples. And we're going to wait for our temperature to finalize. Looks like our final temperature for this one is 12.5 degrees Celsius. For our final trial, we're going to compare cold water to hot water. The mass of our warmer water in condition number 3 is 190.8 grams. The mass of our cooler water is 114.9 grams. Once again, we'll take the initial temperature. The initial temperature of our warmer water is 85.9 degrees Celsius. The initial temperature of our cold water is 8 degrees Celsius. Once again, we're going to pour 1 into the other. I'm going to give it a little swirl to mix our 2 water samples. And then we're going to wait for the temperature to stabilize. The final temperature of our last trial here is 54.7 degrees Celsius. The last thing that you need to do in this experiment is to determine the change in temperature for each water sample. Remember, delta just means a final minus an initial. So if you want to find the change in temperature for the warm water, you're going to take your final temperature minus the initial temperature of the warm water. Similarly, to find the temperature change for the cool water, you're going to take the final temperature minus the initial temperature of the cool water. Now, one of these change in temperatures will be positive and one will be negative, and that's okay. Remember, a negative change in temperature just means that something cooled down.